Today we are going to study positive real function. Now what is the positive real function? First statement, fs is real for s real. What does it mean? Suppose I am taking as plane. This is sigma and j omega. This is your s plane because s is nothing but sigma plus j omega. Now this is your s plane sigma and plus j omega, and I am taking f of s plane where this will be imaginary fs and here it will be real fs. Now what does it mean? If fs is real for s real, if this f lies on this real axis, then fs will also lie on the real axis. This is the first point of for consideration of positive real function. And second point is, for real part of fs will be greater than equal to 0 for real part of s greater than equal to 0. Means here in all the area the real part of s is greater than 0, then it should map on the real part of fs must be greater than equal to 0. So the meaning is this one. These two statement fulfills your positive real function, but it is very difficult to find out with these two method. So one scientist had given some rule to find the how to find the positive real function, taking determination of these two things. Now what is that? Suppose the function fs is of ns by ds, and we want to make it clear that this is this positive real function or not. Then we are going to apply some rule over here. What is this? First rule, ds must be Hurwitz. It means the pole, that is the pole of function fs must lie in left half of s plane. So ds must be Hurwitz. Second, after checking Hurwitz criteria, the pole may lie on imaginary axis. If the pole lie on imaginary axis is simple, then we will proceed another step. If it is complex, then directly we can say that this is not PRF. Now when the pole is simple, now taking this, now when the pole is simple, then find the residue. This residue, it is being, how to find this residue? This residue is found out by using partial fraction. This you will learn in singular class. After partial fraction of that function, you will find that residue, and when you will find a residue, suppose k naught is your residue that come. If it is complex or negative, then we will say this is not PRF. Now k naught is positive, then we can say this is a PRF. Means we are checking, first we are checking ds Hurwitz, second we will be checking this pole may lie on imaginary axis. If pole lies on imaginary axis, it must be simple or complex. Complex, that directly we can say that this is not PRF. Now when we got to know this is simple, then find the residue. If the residue is complex or imaginary, then directly we can say this is not PRF. and when k naught is positive, then also we cannot say it is not PRF. Again we have to go for the third stage. What is that? The third stage? The third stage give is real part of Fs is greater than 0 for all s. Now this we find only on j omega axis. This is the simplification that has been made by that scientist, those who has given this rule. Because if real part of f is greater than for all s, means we have to check for all the value, but we are checking on j omega axis, or real part of f j omega must be greater than equal to for all omega. So this is what we got it. Now suppose Fs is of ns by ds, then how we will be checking real part of f is greater than equal to 0 for all omega. For that we are going to make some simplification. Now see, numerator will consist of some even part and some odd part. M we are terming for even part and n for odd part, and 1 is given, subscript is given for numerator. Similarly this ds will be m2 plus n2. Now we have function f has, which was nothing but ns by ds is equal to m1 plus n1 by m2 plus n2. Now to make it simplification easier, now let us multiply with m2 minus n2 dividing m2 minus n2. Now we are dividing by these two common factor. Now what we are going to get it? m1 m2 minus n1 n2, m2 square minus n2 square plus n1 m2 minus m1 m2 by m2 square minus n2 square. Now we need to check here what is this term and what is this term. Now we can say this is your real part and this is your imaginary part. How? Because this is your product of odd into even will give you odd, minus product of even into this is n2 odd will give you odd. Odd minus odd, it is going to give you odd function. This is odd function. If I put s is equal to j omega, then this is going to give me imaginary, and we need not to check the imaginary part. Here we are there to check the real part. Real part of fs must be greater than 0. This we are going to check. So we will not check this part. Now we are here with m1 m2. This is the product of even term, and this is n1 n2 product of odd term. It is going to give me even minus even, it will give me even, and this is square, this will be even. So this is the point that we need to consider. Now we need to check real part of fs is greater than 0. It means m1 m2 minus n1 n2 by m2 square minus n2 square, we will be subtracting to s to j omega is greater than 0 for all omega. Now if I break m2 square minus n2 square, it will going to give m2 plus n2, and this is m2 minus n2. And what is this function? This is nothing but ns by ds. What we have given? We have written ds to be m2 plus n2, and this is m1 plus n2. So ds is m2 plus n2. So this will be your ds. And what will be m2 minus n2? This will be nothing but d minus s. Now this is nothing but if I m2 square minus n2 square, if I put s is equal to j omega, then this will be d of j omega, the magnitude, and this will be always greater than 0. Means lastly we came to conclusion we have to check this one to be greater than 0, and somehow we found that this is greater than 0. Now we are left with this portion only, m1 m2 minus n1 n2. So we will be checking m1 m2 and n1 n2. Now take writing this term m1 m2 minus n1 n2 must be greater than 0 for all omega. Then this is your third point. Then we can say this is a PRF. Again we need to check one and two more step, but right now we will be checking m1 minus m1 into m2 minus n1 into n2 must be greater than 0. Subject to the condition for all omega means m1 into m2 minus n1 into n2, where s is equal to minus omega square. S square must be equal to minus omega square, because s is equal to j omega, then s square is equal to must be j square omega square. This is nothing but minus omega square. Now it is very tough to check at omega square because the equation will become complex. So what we are doing, we are replacing this y term x, then we will be checking each m1 into m2 minus n1 into n2 s square minus s square is equal to minus x. Now this will simple become a polynomial in x, and just we will check is the equation is greater than 0 or not. Now this is the third point that we have taken into consideration. Now the fourth point, poles and zeros, the poles and zeros, fourth point of fs, that is ns by ds, must be real or maximum it can be complex conjugate. And the fifth and the sixth point, making both common, highest and the lowest power difference between ns and ds can be maximum 1. If there are more than 1, then it will have a multiple root at origin or infinity, which will lead to instability. So this point we need to take care of. Now we are taking an example, a simple example. Suppose I am taking this one. If fs is equal to s plus a, s square plus bs plus c. Now we need to find a condition for ABC. For what ABC? This is a PRF function. Now if b is 0, then what will be our function? S plus a, s square plus c. Then what we can say, then we are going to break this into two parts, s by s square plus c plus a by s square plus c. Now we are going to check for this and this. If we subtract s square is equal to minus s is equal to j omega, then what will be this value? A by j omega square minus c, a by c minus omega square, and this value can be negative. So we want ABC to be, if b is 0, then from here what we got, if this want to be the PRF, then a must be 0, then only this will be not negative. Now suppose the second case, if b is not equal to 0, then what will be our equation? Now the equation is s plus a s square plus bs plus c. Now we need to apply the condition. This denominator we need to apply. What we need to apply? The real part of this in numerator and denominator we need to apply real part of fs is equal to greater than 0 or not. Means we need to apply this one m1 into m2, this is m1 into m2 minus n1 into n2 for this function. Now writing m1 into m2 minus n1 into n2 must be greater than 0, subject to the condition h square must be, h square is being replaced by minus x. Now what is m1? If you see m1, this is even part of numerator, there is no, the even part is a. Now writing a. What is m2? The even part is s square plus c. Now s square plus c minus, what is odd part of this? S. And what is odd part of this? bs. And it must be greater than 0 for s square minus x. Now if I put s equal to minus omega square, this will become quadratic, means quadratic square equation. So we don't want that equation. Now I am putting s square is equal to minus x. A minus x plus c minus b s square. Now if I put x square is equal to minus x, then a minus x plus c, this will be plus bx, or we can say ac plus b minus a into x must be greater than 0 for this to be PRF. Now if this whole equation must be greater than 0, it means b must be greater than or equal to a. So this is the condition that must be applied over here to check that our equation is PRF or not. Now I am taking another problem, 3 problem, and we will be checking if that function is PRF or not. Now for the equation of this kind, what was the equation? This is the equation. For equation of this kind, what we came to know, that b must be greater than 1a for this function to be PRF. Now I am taking example 1, s plus 2 by s square plus 4s plus 2. Now here this is your b and here this is your a. Means b is greater than a, it means this is your PR, positive real function. Now second I am taking s plus 2, s square plus s plus 2. Now here this is a and 1 is b. Here b is less than a, so not NPR, not PRF. Now third, s plus 1 by s square plus 2. Here b is equal to 0, then for this to be PRF, a must be also equal to, so this is not PRF. Now this is how we have shown. Now I am going to take one more example and we are going to see is the function is PRF or not. Now take fs is equal to s square plus 4 s square s cube 3s square plus 3s plus 1. This is the function that I have taken. Now let me take in another sheet. This is the function we have taken. First what we need to do, we need to apply the Hurwitz. This is ns by ts. Now we need to apply the Hurwitz. Is this function for that applying Hurwitz? Now I am applying RH criteria. This is s cube, this is Hurwitz criteria, not RH criteria. We are taking we are solving by RH criteria just to see whether the function is Hurwitz or not. We are checking the poses is left half of s plane or not. S cube h square s1 s0. What will be s cube? 1 3 and the factor of s square, it is 3 and 1. 3 3 is 9 minus 1 8, 8 by 3, and this is 1. Now if you see this first column has no negative sign or it didn't stop prematurely. So this is Hurwitz polynomial. Mean first case we got it. This is Hurwitz polynomial. We can do by successive division also. Now second point, we need to check, are there pole on j omegas? There is no pole on j omegas because this has not. There is no pole on j omega axis. How we came to know? Because this has not stopped prematurely. Now third, we are going to check for the real part of that is m1 m2 minus n1 n2 must be greater than 0 for x square is equal to minus x. Now what was our function? This is our function s square. Now writing again the function s square plus 4 by s cube plus 3s square plus 3s plus 1. Now this is what will be our m1. It is going to be even part 3s square plus 1. This is nothing but your m1. And what is m2? m2 is s square plus 4 and minus n1 into n2. What is n? There is no odd part, means 0 multiply what is odd part, s cube plus 3s, means this is 0. Now we need to check for s square minus x, this value. Now if I put s square is equal to minus x, then this is become 3 minus 3x plus 1 and this will become minus x plus 4. So this is the equation of ax. It is 1 minus 3x and 4 minus x. Now this is definitely going to be negative for some x. So you can say this function is not PRF. Now we are going to look another problem. Now let me take a different sheet. Now this is second problem, s square plus 3s plus 2 s cube plus 4s. Now we are going to check ts, is it Hurwitz or not. S cube plus 4s. Now for that what we need to do, we cannot divide it by the remaining term, but it can easily be seen as common s square plus 4. It has a pole on plus minus j2. It has a complex pole. Now we got it complex pole. Now what we will do, we will check for the residue. Now if fs is function s square plus 3s plus 2 s cube plus 4s. Now if I write the residue form a by s plus bs by c s square plus 4, and if I solve this equation, then we are going to get a is equal to 0.5, b is equal to 0.5 and c is equal to 3. Means all the coefficients are positive. Then we need to proceed it further. If somehow the coefficient would be negative or complex, then here only we would have been saying this is not PRF. Now this is the second part we have done, the checking. The first part we have done the pole is left out. Whether you check it is Hurwitz equation, Hurwitz polynomial, or saying the pole is in left half or not. Now we have directly checked the pole is complex, and from that complex we came to know this has a residue which is positive. Now you need to solve this equation. Now step 3, we need to directly go to m1 m2 minus n1 n2 must be greater than equal to 0. Now if you see this equation, what will be m1 m2? Now this is your odd only, so there is no even part, means 0. Even part of m1 is s square plus 2 and even part of denominator is 0. So this is value will be 0 minus n1. What will be odd part? Odd is 3s, and what will be odd? S cube plus 4s. This is your odd part, and thus we are subject to s square minus x. Now if I see minus 3 s square plus 4, put s square is equal to minus x, then this is going to be 3x, and if I put 4 minus x, then we can say that this equation is not PRF, because here it confirms that for certain value of x, this value will be, this a of x will be negative. So we can say this function is not a PRF. So this is all about the PRF, means positive real